Today I have a couple more algebra skills videos to cover a few concepts in greater detail that we did not get to in class today. The first one, you're asked to solve for f given this formula. As usual, you may want to pause and try on your own. I'll distribute 5 over 9. C is equal to 5 over 9f minus 32 times 5 over 9. When you multiply 32 by 5 over 9, I like to think of this as 32 over 1 times 5 over 9. We'll multiply through in the numerator. We'll multiply through in the denominator. C is equal to 5 over 9f minus 160 over 9. We're solving for f. We want to isolate f, and so I'll add 160 over 9 to both sides. You have two options. You can divide by 5 over 9 or multiply by its reciprocal, 9 over 5. I strongly recommend multiplying by 9 over 5. It saves you a step. You need to wrap the left side in a pair of parentheses and multiply by 9 over 5. 5 over 9 times 9 over 5 reduces to 1. We have isolated f. And I'm just going to go ahead and distribute this 9 over 5 because I want to make a point. 9 over 5 times c plus 160 over 9 times 9 over 5 is equal to f. Now, we're multiplying 160 times 9, and we're dividing that by the product 9 times 5. 9 over 9 reduces to 1, and 160 over 5 reduces to 32. F then is equal to 32 plus 9/5 c. And you might recognize this as the conversion from degrees Fahrenheit to degrees Celsius. Next example, we want to solve for w. We want to isolate w. Notice that L and L sub 0, or L naught, are not the same variable. They are two different variables. So I'll start by subtracting L naught. L minus L naught is equal to K divided by 2 times W. The goal is to get W by itself, to isolate it. So I will multiply by the reciprocal, 2 over K. I'm going to wrap the left side and do the same thing. 2 over K times K over 2 reduces to 1. And so one way you can think of this is W is equal to 2 over K times the quantity L minus L naught. Of course, you could distribute 2L over K minus 2L naught over K is equal to W would be an alternate way to write that. Next example. We want to expand and simplify, and let's talk about order of operations first. I need to square this binomial by two terms, x plus h, 2. So I'm going to do that first. So 2 times x plus h times the quantity x plus h minus 2x squared over. Now x plus h, these parentheses really are not doing anything for us. So what we have is x plus h minus x, which reduces to h in our denominator. Plenty of work to do in the numerator still. I'm going to FOIL this. So x times x is x squared. X times h is plus xh. H times x is plus xh. H times h is plus h squared. That is getting multiplied by 2. I'll subtract 2x squared, still dividing by h. Now, we can clean this up by combining like terms. xh plus xh is 2xh. So I have 2 times the quantity x squared plus 2xh plus h squared minus 2x squared over h. I will distribute my 2. I'll work my way over here. 2x squared plus 4xh plus 2h squared minus 2x squared over h. And we can combine like terms. So 2x squared and negative 2x squared is 0. Leaves us with 4xh plus 2h squared over h. Last but not least, we can factor an h out of the numerator. H times the quantity 4x plus 2h over h. And our h over h reduces to 1. We're left with 4x plus 2h. Again, you can check this last step by redistributing the h and making sure that you end up with what you had before. In this case, that would give us our 4xh plus our 2h squared. So this is the fully expanded and simplified version. Next example, you were asked on a homework document to find x and y intercepts. So let's review what we mean by that. An x-intercept is where a graph, so in this case, y equals negative 4x plus 3. It has a y-intercept of 3, and it has a slope of negative 4. So just a sketch, it would be a decreasing linear function with a y-intercept of 3. And the x-intercept is where the graph intersects the x-axis. That's what you're being asked to solve for. And the y-intercept is where the graph intersects the y-axis. To find an x-intercept, you put in 0 for y. And to find a y-intercept, you substitute's a better term, 0 for x. So we actually know in this case the y-intercept. It was given to us. If I put 0 in for x and I want to find the y-intercept, y is equal to negative 4 times 0 plus 3. Negative 4 times 0 is 0. I just get y is equal to 3. And that's given. That's your b value. There it is in y equals mx plus b. So my y-intercept is 3. If I want to find my x-intercept, again I would put 0 in for y. So I'd substitute 0 for y. I get 0 is equal to negative 4x plus 3. I'll add 4x to both sides, so 4x is equal to 3. I'll divide both sides by 4, and I get x is equal to 3 over 4. So my x-intercept right here is 3/4. My y-intercept right here is 3. Next example, again, find the x and y intercepts. Well, if I want to find the x-intercept, I have to put 0 in for y. So let's start there. 5x minus 2 times 0 is equal to 4. Well, 2 times 0 is 0. 5x is equal to 4. Divide both sides by 5. X is 4/5. And my y-intercept, I put 0 in for x. So 5 times 0 minus 2y is equal to 4. 5 times 0 is 0. Negative 2y is equal to 4. Divide by negative 2. And y is negative 2. So we have a y-intercept of negative 2 and an x-intercept of 4/5. Now, let's talk about two other representations of that, and we'll be done. If or maybe some other ways to find that, I guess is what I'm trying to say. If I wanted to put this into slope-intercept form, y equals mx plus b, I could start by adding 2y and subtracting 4. That would put us here, 5x minus 4 is equal to 2y. And then divide everything by 2. Notice everything gets divided by 2. And that gives me y is equal to 5/2 x minus 2. Again, the 5/2 x comes from this, 5x divided by 2. The minus 2 comes from this, negative 4 divided by 2. If you have a binomial, let me circle that, binomial, 2 terms, divided by a monomial, 1 term, you can divide each term, in this case by 2, and I've got my slope-intercept form. Well, from the slope-intercept form, you could also find your x and y-intercepts. Notice your y-intercept is negative 2. And if I was to sketch that graph, of course I'd have a y-intercept of negative 2. There it is. and a slope of 5/2, which I'm not worried about the scale here. I'm just going to sketch an increasing function. I know it's increasing because my slope is positive, and so a sketch, don't worry about the scale right now, would look something like that.